So today I'm going to tell you about the ultrasonic welding machine, how it works, what kind of material we can weld with that, and what is the difference between the sewing technology and the welding technology basically. So this is how the machine looks like. The machine has a pedal beneath. It's just like the sewing machine. When we want to weld, we just press it and the machine basically do the continuous welding process. This is how the digital interface looks like. You can see different parameters. I will come to that. And then in the welding machine, instead of sewing where we have needles, we have a anvil wheel which is here, and then we have a sonotrode which is beneath. So basically how it works, the sonotrode creates vibration in ultrasonic zone, and through these vibrations the friction is generated and the heat is generated, and then we will weld our welding material. So here you can see one seam. You can see the stitch formation with the sewing thread, this white color, this way this is black colored thread, and then we have a welded seam. So the first difference that you will notice here, that in a seam with the sewing you will have a third element instead of two sewing layers, plus the third element is the sewing thread. In a welded seam, we do not have this third element of sewing thread. So how do we actually then make a weld or make a seam? The key thing in a welded seam is that the material must have some thermoplastic properties. So you see here, this side of material, this looks like some plain fabric, but this side has a little bit of shiny surface. So basically this is a thermoplastic coating on that surface. And what we basically do in any welding, we try to melt this coated surface and press it under pressure, and then basically a welded seam takes place. So now I will come to the anvil wheel. You can see here this golden part. It's a rotating anvil wheel. It has this dotted surface, if you can see, and the sonotrode below is just a plain surface. So we can have different type of welding seams. Right now you see this dotted surface. We can have some other type of anvil wheels too. Just like this. This is just a plain surface. Approximately the width of the seam is 1 centimeter. This is also a plain surface, like this, or certain patterns, certain widths. This lining on the seam. So there are a bunch of different type of seams that we can choose to weld our material. So whatever we want to change, what else, for example, if I want to have this welded seam width, what I will do, I will take this anvil wheel, move the screw, take this one out, insert this one, and then I have this welded seam. The next feature is these are different parameters of welding. You can see here the power with which the welded seam will take place. Then we have the force. At the moment this is 8 Newton. With this anvil wheel and the sonotrode will press the welded material in between, like this one. This is the force with which this will come down and then we'll press it. And then we have this speed with which we can move our material through the welding zone. And another feature that we can have is either the fourth, or we can also have the feature of the gap. So the gap means the distance between the anvil wheel and the sonotrode. So if we want to keep a specific distance between both of these elements of the welding, then we can just decide, okay, let's say I want to have just 1 millimeter of the distance between the two. So if there is some thick space come during the welding, for example, where multiple layers are coming, more than two in any particular case, then the force will be increased automatically to maintain this continuous distance. So the next step is that I have to weld these layers of materials. You see that one side is having this shiny thermoplastic surface. What I will do during the welding, the sonotrode will create these mechanical vibrations, and these mechanical vibrations will bring this thermoplastic material to the melting point. Normally the thermoplastic materials, they are melted between 225 degree to maximum 300 degree centigrade, mostly in the textiles materials which are basically used. And that's how the energy will be given to this thermoplastic surface, and then the pressure will come from the anvil wheel to the sonotrode, and then a seam will take place. So now I have these parameters I have set. I will place the material in between the anvil wheel and the sonotrode. I will press the paddle, and the anvil will come down, and then when I will press it further, just like a sewing machine, the machine with the speed which I have already at now 1.5 meters per second. So when I press at the back, the anvil will go up, and then I will see if the weld has taken place. So you see there is no weld has taken place, but a little bit of dots you can see, so something has happened. So this means the parameters that I have chosen, these are not good enough or fair enough to melt the thermoplastic material. So this means we have to come back to our to the screen and see what we can do. So the power seems to me 300 watt is fine. What I can do, I can maybe increase the more force, because the material was a little bit loose, I believe. Let's say 8 Newton is fine, or 9 Newton. And what I can do is maybe I can reduce the speed. For example, I will just press the minimum minus sign. So this means I will give more time to anvil wheel to melt the thermoplastic material. So for example, let's say it 1 meter per second, 1 meter per minute. The force is 9 Newton, the power is the same. And now I will come back and see with my material if I'm able to weld it. So you can see here, no weld has taken place. I will press it, place it again between the anvil wheel, press my pedal. By first pressing, you can see that the anvil will just come down. No sonotrode movement has taken place. This means no energy has taken place. If I press at the back of the pedal, just like in sewing machine, where the presser foot goes up, here this anvil wheel will go up. And I just press it down again and see material is fixed here. And then I will press further the pedal on the front side. It doesn't matter how deep I press, the machine will move it 1 meter per minute, what I have set already. So now if you see here, there are a lot of deep dots you can see, because we have increased the pressure, and you can see that this impression is on the surface of this textile material. And now let's see what happens to our thermoplastic material here. And you can see here, if I try to pull it apart, the thermoplastic coating is ripping apart. So this means that the weld is so strong that the joining force between the fabric surface and the coating is weaker than the weld itself. So this means is apparently this is a nice weld has taken place. So what is important in this perspective to understand, each material, each coating has its own special welding requirements. So we have to, for example, if I am having this material, it might require not these parameters that I have used for this material. They might require some other machine parameters. So that's why it's an iterative work where we have to find different specific optimal machine parameters to find the optimum welding conditions. And likewise, if I have welded this material with this particular anvil wheel, if I'm going to change my anvil wheel and maybe change it to maybe this one or this one, so the same machine parameters that I have set earlier for this seam might not be valid. So it's every time with anvil wheel, with the width, and we have to find the optimum parameters. So that's how basically a ultrasonic welding machine works. Thank you.